Hello, so this is Mr. Parsons again. This is all about converting forms between different quadratic functions. So between vertex form and standard form into vertex form. So there's benefits and drawbacks of each of these forms. And sometimes you have to translate between the two of them. So by the end of this, you will know how to convert between the different forms of quadratic functions. So, the benefit of the vertex form, obviously, is it tells you the vertex right away. So you know that it's a max or min, and you can tell, that halfway point and the highest point. The drawback is if you're looking for like the y-intercept or the x-intercepts or the solutions, it's much harder to tell. While in standard form, it tells you the y-intercept right away, which is c, and it can be used to find those x-intercepts or those solutions to the system, which we're going to get into later. So what you'll notice is they both have their forms. So a, b, and c in the standard form, and a, h, and k in the vertex form. B and C are in the standard form, H and K are in the vertex form, but A is in both. So what you'll notice is that A stays consistent from one form to the other. So no matter what, those equations are going to start with that same number. So first thing we're going to do is convert standard to vertex form. It's the same steps that we have been doing when we're graphing in standard form. You have to calculate the vertex. So first, opposite of b over 2a. You take that value, you substitute that in, you have your h and your k, and you plug it in, and you write out the equation. So, converting from standard to vertex, here are some examples. So, find your a, b, and c. Now, do the opposite of b over 2a. So the opposite of negative 4 is going to be 4 over 2 times 1, which, okay. So it becomes 4 over 2, x is 2. Now I'm going to take that and I'm going to plug it into the equation. So 2 squared minus 4 times 2 plus 6. I'm going to get 4 minus 8 plus 6. So my y is 2. So that is my vertex. So now all I do is I plug it into my vertex form. So my A comes down from my original equation, and I plug in my vertex, and I'm done. So that's pretty much what we've been doing for graphing in standard form. Now, in example 2, this is the tricky one. Okay. Oh, sorry. This is the final example. So you can write it with the 1 or without the 1, doesn't matter. So example 2, you get 6x squared minus 10. You'll notice when I label this, b is 0. You don't see an x there. And when b is 0, this is where the trick comes in. But I'm going to follow through these steps and you're going to see where the trick is. So negative 0, okay, divided by 2 times 6. So that's 0 over 12, so x is 0. I then plug it in, and I get y is negative 10. So my vertex is 0, negative 10. So when I plug this in to my vertex form, you'll notice that it's x minus 0, and we never write it like that. So my final equation would actually be that 6x squared minus 10. You'll notice that when b is 0, the vertex form and the standard form for both of these equations are exactly the same. So it only happens when that b is 0. It's a little trick to save you a little bit of time. So now let's go through converting from vertex to standard. This requires a little bit more math. So first off, you write out that vertex form, that x minus h squared, into 2 sets of parentheses. And you're going to FOIL or double distribute those parentheses, okay? Then you're going to take that And you're going to keep it in a parenthesis because there's going to be an a value that's out in front. And you're going to have to combine those like terms and distribute that a value in. And then you combine your like terms and put it in the correct order. So what do I mean by writing out that x minus h in two parts? So that means I'm literally writing it x plus 7 times x plus 7, because squared really means something times itself. Okay? So now what I'm going to do is I'm going to distribute, double distribute, in those two parentheses. So what I mean by that is I'm going to do x times x and x times 7. I leave the -4 on the outside, so it's going to be x squared plus 7. And then I'm going to distribute the 7 into the second parenthesis, and I'm going to get 7x plus 49. I keep that in parentheses, and I'm going to have minus 12 at the end. Now you'll notice inside the parentheses, I have those two 7x's, so I'm going to combine them to 14x. Now I'm going to distribute that -4 into each part, and you'll notice that I left the minus 12 at the end. And you notice once I distributed that -4, those parentheses go away. Now I combine my like terms, and that is my standard form. Let's try this with another example. So again, the first step is write out those parentheses twice. So x plus 2 becomes, it doubles. I distribute. So I leave the 1/2 out in front. X times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. And then plus 4. I combine those middle terms, that 2x plus 2, x. I get 4x. Now I'm going to distribute the 1/2 in. So 1/2 times x squared is 1/2 x squared plus 2x plus 2 now plus 4. Because all I'm doing with that 1/2 is I'm just taking and dividing it by 2. I combine those last terms, and I'm left with my final answer, 1/2 x squared plus 2x plus 6. That is how you convert between vertex to standard and standard to vertex. So thank you for listening. Again, I'm always open for questions. Please feel free to contact. Thank you.